Boom, boom, boom. Rational root theorem. Okay, you did this in Algebra 2. Hopefully you remember a little bit about this. But the rational root theorem is this. You take all the possible factors of that, gotta change to skinnier, and all the possible factors of this coefficient, and you put this over this as a fraction. So all the possible factors of 10 are 1, 2, 5, and 10. All the factors of 1 are 1. So all the possible factors at work are positive and negative 1 over 1, 2 over 1, 5 over 1, and 10 over 1, which is this. Okay? So, if we know all the possible factors, then we can do synthetic division. 1, 4, negative 7, negative 10, and find the answers. Now, because this is multiple choice, it makes our life so much easier. But see how it's 1, 2, negative 1, 2, negative 5, or 1, negative 2, 5? Because we're not going to use this one because there's only 3 answers. Okay? If it's to the third power, there'll be 3 answers. Now, could it be negative 1? Yeah, it could be negative 1 3 times. Okay? So we're going to just start with 1 to see if 1 works. 1, 1, 1, 5, 5, negative 2, negative 2. Does that give us 0? No. So 1 doesn't work. So let's try negative 1. Drop the 1 down, negative 1. 3, negative 3, negative 10, 10, 0. It works. Okay, negative 1 is a root. What's another root? Well, I'm guessing 2 will be a root. So you go with what is left over. Drop down the 1. 2 times 1 is 2. Add, you get 5. Multiply, you get 10. You get 0. Okay? So the roots are negative 1, 2, and what's left here is 1x plus 5 equals 0. So if you move the 5 over, you get negative 5. Those are the 3 roots. Now, when it's multiple choice, life is easy peasy. If there's not multiple choice, you have to work a little harder to find them. All right, rational root theorem for this one. Okay. Factors of 75 are 1 and 75. 2 doesn't go in there. 3 goes in there 25 times. 4 doesn't go in there. 5 goes in there 15 times. 6 doesn't go in there. 7 doesn't. 8 doesn't. 9 doesn't. 10, 11, 12, 13, 14, 15, 25, and 75. Okay? Those are all over what goes into 15. 1, 3, 5, and 15. Then we put all the possible combinations of these over each other. 1 over 1, 3 over 1, 5 over 1, 15 over 1, 25 over 1, 75 over 1. Then 1 over 3. 3 over 3 is 1. We've already listed it. 3 over 5. Or wait, no. Let's go in this order. Over 3s. So 5 over 3. 15 over 3 is 5. We already got it. 25 over 3. And 75 over 3 is 25. We already have it. All right. So then we have 1/5. 3/5. 5/5 is already there. 15/5 is already there. 25/5 is already there. 75/5 is already there. Then 1/15. 3/15 is already there because that's 1/5. 5/15 is 1/3. 15/15 is 1. 25/15 is what? 5/3. And 75/15 is there. So these are all the possible rational roots. Oh, 5/3 I already had listed right there. So these are all the possible rational roots, positive and negative of all these. So is it A or B? I think it's A, because they don't have 1/5. Oh, they do have 1/15th here. But what are they missing in this list? Oh, they're missing 75. Yeah. Uh-huh. So what are the rational roots for that? Well, I'm not going to show you the answer yet. I'm going to work a little harder. Okay? So you have a 15, a negative 361, a negative 347, and a negative 75. So if we try a 1, do you honestly think 1 will work? See how it gets really big and then a lot smaller? Okay. Maybe a 3 might work. So you drop down 15. What's 3 times 15? 45. And then negative 316, right? And then that gets, 900 and something. That's not going to work. So it's got to be like 25 then. Let's try 25. What's 15 times 25? That's a huge number. 15 times 25 is what? 375. So then that makes a really small number. That's like what, 14? 25 times 14 is 350, which makes it 3, which makes 75, which makes 0. So that worked. Yay. So we know 25 works. So because this is multiple choice, we'll know negative 1/3 works and 3/5 work. But if that doesn't work that way, then I would do the quadratic formula to this. Yes. I wouldn't know, probably. Back to the help desk. Just the login screen?
I have no clue how to sign in. Because I have to be on USD Wi-Fi to sign in to whatever. And I can't sit on campus. I'm going to be crying.
But if you have to be in USD Wi-Fi, you'll have to go back to campus to do it.
There's other ways to log in under another domain, but I don't know what any of that means.
Okay, so then it would be your domain name might be coyotes.usd.edu. I don't know what your domain is.
No, I need to get a different domain that isn't the USD one.
Well, no, it's got to be a USD domain. I think you have to go back to campus and get it squared away. All right. So then, once you get to this far, and if you don't have multiple choice, what do? Well, you could keep trying this, but this list is long, right? This is 15x squared plus 14x plus 3. So you could try factoring it, or you could do the quadratic formula. negative b plus or minus the square root of b squared. 14 squared is 196. Minus 4ac all over 2a. So it's negative 14 plus or minus the square root of 196 minus 180. Oh, yeah, over 30, which is negative 14 plus or minus the square root of 16 over 30, which is negative 14 plus or minus 4 over 30, which this is negative 18 over 30, which if you divide both by 6 is negative 3/5. Or negative 14 plus negative 4 is negative 10 over 30, which is negative 1/3. Okay? All right. So, for this one, find all the real zero functions, find the missing exact values when possible. Okay? So, how many roots should this have? Should have 3 roots. Okay? Now, it could have one rational and 2 or one real and 2 unreal, and then or 1 rational and 2 irrational. Okay, so let's try to figure this out. Okay, so if we have 21, the factors of 21 are 1, 21, 3, 7, and that's it. 1, 3, 7, 21. And the other ones are 1 and 2. Okay, so your factors are 1, 3, 7, 21, then 1/3, 1/7, 1 over 21, wait, I'm upside down, aren't I? It's that over that. Sorry. It's that over that. So 1/2, 3 halves, 7 halves, 21 halves. Okay, those are our 8 possible roots. Okay, so if we do this, 2, -7, -6, 21. The easiest one to start with generally is 1. 2 makes 2, makes -5, makes -5, makes -11. It doesn't work. Okay? So 1 doesn't work. Let's try 3. 3 times 2 is 6, -1, -3, -9. That was close, but not quite, because that would be -27. So we're close to 1 and 3, so let's try 3 halves. 3 halves times 2 is 3. Add, we get -4. 3 halves times -4 is what? -6? And we get -12. 3 halves of -12 is 18. Close, but no cigar. How about a -3 halves? 2 times -3 halves is -3. Get -10. This way we get 30 over 2, which is 15. 15, it gives us what? -9? +9, which gives us -27 halves. Still not quite it. -1/2. Once we find 1, then the rest is easy. So this gives us -1, -8, +4, only -2, and that doesn't get us close to 21. Seven gives us 14. 7, 49, way too big, way too big. How about 7/2? Gives us 7, 0, 0, -6, -21. Ooh, we got there finally. Okay, 7/2 is a root. What we're left with is, this was x cubed, so this is x squared. 2x squared minus 6 equals 0. So 2x squared equals 6. Divide by 2. X squared equals 3. How do we get x alone? Square root of each. X equals plus or minus the square root of 3. So we have 2 irrational roots and 1 rational root. The rational root is 7/2. The irrationals are plus or minus square root of 3. Okay, let's do that again for one more problem. Then I'll give you the 4 problems, and then that'll be it. Okay, so how many roots are going to be here? 4 roots. Okay, now there's a 1 in front of here, which makes it easier. Then it's just the factors of this: 1, 3, 5, and 15. So 1, -2, -8, 10, and 15. So we go 1, 1, 1, -1, -1, -9, -9, only gets us 1, doesn't get us there. So then let's try 3. 3, 1, 3, -5, 15, -15, -5, -15, 0. Hey, it worked. So 3 is a root. But since there are 4 things left, we can't just factor it or do the quadratic formula. We need to do something else. Now, see how there's just 1s and 5s? We already tried 1, and we know that doesn't work. We didn't try -1, but let me try a 5, because there's so many 1s and 5s involved. Try 5. 1 times 5 is 5. Gives me 6, gives me 30. Nope, that doesn't work. So what about a -5? 1 times 5 is -5. Add, we get -4, +20. Nope, that's too big. That doesn't work. What if we try 3? No, 3 is not going to work. How about a -1? That might work. -1 times 1 is -1, gives us 0, gives us 0, gives us -5, gives us 5, gives us 0. There we go. So -3, or 3 and -1 are the rational zeros. To find the irrational zeros, this is x squared, because this was x to the 4th, and this was x to the 3rd, so this is x squared, minus 5 equals 0. X squared equals 5, take the square root, x equals plus or minus square root of 5. Okay? If we know the possible rational roots, then that helps narrow down which ones we try. Okay? So that's what we're going to do, 4 problems, and then after lunch we'll do a quiz review and a practice quiz, and then you come back Tuesday, we'll take a quiz.